Hey, geometry students. Today we're going to talk about ratios and proportions, and this is what we're going to need in order to be able to talk about similar figures in 8.1. So, first of all, what is a ratio? It's something it demonstrates a relationship between two different quantities. So, it could be anything. It could be the ratio of flour to sugar in a recipe. It could be the ratio of students to teachers in a classroom, or it could be the ratio of side lengths in similar figures. We'll get to those in the future, but for now we're going to talk about basic ratios here. So one common ratio is flour to sugar in a recipe. So if I was going to make cookies or something, and it calls for 3 cups of flour and 2 cups of sugar. Spelling is hard. Okay, there we go. So this is a ratio, and there's 3 main ways that you can write a ratio. The first way is as a fraction. So in this case, 3 cups of flour to 2 cups of sugar would be just the fraction 3 over 2. The second way is to just put a colon between the two numbers. So it would be like 3 colon 2. That would stand for a 3 to 2 ratio. And then the third way is just with words. So the words way would be just 3 to 2. Okay, so there's our ways that we can write them. So now we want to actually be able to use these. So if I wanted to double the recipe, this is going to be a simpler application of a ratio. If I want to double the recipe, then I would need 6 cups of flour and 4 cups of sugar. So that's an easy way that we can see ratios and proportions in action. But what if instead I had something like, let's say with this same scenario, it's still a 3 to 2 ratio here. But instead, let's say I have 7 cups of flour. And I want to figure out if I want, like, how many cookies basically can I make with my, or not how many cookies. If I was going to use all 7 cups of flour, how many cups of sugar would I need to use? That's where we set up something called a proportion so that we can solve it. Because off the top of my head, you know, going, okay, if I know it's 3 cups of flour to 2 cups of sugar, that's a little bit harder to figure out if I know I want to use 7 cups. So here we go. I've got my 3 cups flour, 2 cups of sugar. I'm going to use the fraction form of that ratio. And then remember, I have flour on top here. So I'm going to put 7 cups of flour on the top of my second fraction. And then I don't know how many cups of sugar I'm going to use. That's what we're trying to figure out, right? So I'm going to put just an X there. So now we've set up something called a proportion. And in order to solve a proportion, you need to do something called cross multiplying. So what I'm going to do is I'm going to multiply the 3 and the X, and I'm going to bring it down so that now we have 3X. And then I'm also going to multiply the 2 and the 7 and bring it down, so that gives us 14. And now we have the equation 3x equals 14. So we just cross multiply, multiplying on the diagonals and setting them equal. And now this looks like something that we know how to solve, right? We just divide by 3 on both sides, and we get x equals 14 thirds. And so 14 thirds, if you were, you know, measuring cups of flour and sugar, that wouldn't be the easiest number to measure. So what I would probably do after that is change it into a mixed number. If you're just solving ratios and proportions problems, usually I'm fine with you just leaving it like this. But if you did want to change this into a mixed number to make it easier to understand, what you could do is figure out, okay, 3 times 4 is 12. So I know that I've got 4 full cups, and then 14 minus 12 is 2. So 4 and 2/3 is the same as 14/3. So either of these answers would work for the amount of sugar you need and for what x is equal to. Okay, so that's one type of proportion problem. Let's do another proportion example. Okay, so for our next one, it's going to be very similar to the one that we just did. We're going to go x over 12 equals 3 over 4. Okay, so we're going to do the same exact thing here. We're going to cross multiply. 4 times x is 4x. 3 times 12 is 36. This becomes an equation that we know how to solve already. Just divide by 4 on both sides. And we get x equals 9. And that would be our answer. Okay. So that's a fairly basic example, just like the one that we just did. Now we're going to try one that steps up the difficulty just a little bit. Actually, I'll leave that one there. Our second example, we're going to have y plus 1 over 4 equals 2/5. Okay, so sometimes sometimes you'll see ones that have a little bit more complicated of a expression on the top or on the bottom. And in this case, when you have more than one term as part of your ratio on one side, you're going to make sure before you do anything, before we cross multiply, I'm going to make sure I put parentheses around that so that they stay together, so that in my mind I remember these two things are going to stick together. And you'll see why in just a moment, because when we go to cross multiply, when I multiply on this diagonal, I want to rewrite it as 5 parentheses y plus 1, because I want to multiply the 5 by this whole thing. And then 4 times 2 is 8. Okay, so now what I need to do is make sure I use the distributive property here and multiply the 5 by both of these, so we get 5y plus 5 equals 8. And now this looks like an equation that we know how to solve. We subtract 5 on both sides. We get 5y equals 3. Divide by 5 on both sides. And we get y equals 3/5. And that fraction is as simple as it goes. So we're all done. Okay, so that one was a little bit harder, but not too much harder. You just need to remember to put your parentheses around the one that has more than one term. Okay, let's do one last example that adds one little extra layer of difficulty. But not too much. Not ridiculously harder than we just did. Okay, so this one we're going to have x minus 2 over 5 equals x over 3. So now there's a variable on both sides, but it's the same variable. And notice I already put the parentheses around the one on the top because we want to make sure that these terms stay together. So when I go to cross multiply, we have 5 times x is 5x. 3 times x minus 2 is just 3 parentheses x minus 2. So we have 3 times x minus 2 equals 5x. Then I want to distribute and get 3x minus 6. Make sure you're careful when you're distributing. A lot of times people accidentally forget to give it to the second one. So make sure you give it to both terms. Multiply the 3 through to both terms. Then it's equal to 5x. And then here what I'm going to do is subtract 3x from both sides to get all my x's together on one side of the equation. And remember, this is a negative 6 since it's minus 6 right there. So when I bring it down, I want to bring down the sign with it. So negative 6 equals 5x minus 3x is 2x. Then we're going to divide by 2 on both sides. Negative 6 divided by 2 is negative 3. So negative 3 equals x. And as always, when you're doing equations involving algebra and things like that, and you solve for x, it's usually a good idea to go back and plug your number in and double check and make sure it works. In this case, what that would look like is going negative 3 minus 2 over 5 equals negative 3 over 3. Negative 3 minus 2 is negative 5. Negative 5 divided by 5 is negative 1. Negative 3 divided by 3 is also negative 1. So we get a true statement here. So that is the correct answer. Okay, so that's how we solve proportions and how we use ratios. Next time we'll go over how we use ratios and proportions with similar figures, apply it a little bit more to geometry. But this is all the algebra that backs it up. All right, have a great day. See you guys later.